Hello, in this video we will be covering multi-axis steering. Multi-axis steering can be used for applications where more maneuverability is desired, such as when machines are used in tight spaces. This can be beneficial in material handling applications to reduce the amount of area needed to maneuver the machine. Multi-axis steering provides four main steering modes: traditional or two-wheel steer, four-wheel or all-wheel steer, implement steer, and crab steer. Multi-axis uses a virtual axis to set what point the machine is turning around. This is used to determine what steering mode the machine is in. For example, in two-wheel steer, the axis is in line with the rear axle, so the front wheels will turn while the back stay in the same position. In four-wheel steer, the virtual axis will be shifted to between the front and rear wheels. This will result in all four wheels turning at the same time and following the same path while driving. In implement steer, the axis will be positioned behind the vehicle. This allows for wide turns when pulling an implement. In crab steer, the angle of the axis is changed, so the rear wheels will follow that angle. This can be set at a specific angle or can mirror the angle of the front wheels. Multi-axis steering can be used with an OSPE, EHI, EHI and OSP, or just an OSP on the front, with an EHI for the rear axle. This allows multi-axis steering to be integrated into existing steering systems if the machine is compatible. Multi-axis will require inputs such as a vehicle speed sensor, MMI, and a wheel angle sensor. The input messages that must be received over CAN are different for the slave axis. The slave axis must receive the multi-axis MMI, vehicle speed, which is the same as the standard vehicle speed, slave WAS, which can be analog or CAN, and the master WAS message. Once the hydraulics and wiring are completed, Service Tool can be used to set parameters to match the configuration and desired capabilities of the machine. Multi-axis uses its own Service Tool file, located in the multi-axis firmware package. The main parameter pages to be aware of are the peripherals and in-axis config pages. Multi-axis is based on the concept of a master and a slave axis. There can only be one master axis with any number of slave axes. In the peripherals config page, the number of in-axis nodes should be equal to the number of slave axes. The majority of multi-axis machines will only use one node. The in-axis config page controls the position and angle, clamping and ramping, as well as the closed loop gain, set point clamp, and wheel angle limit. The in-axis position clamping determines how far the virtual axis can move from the original axis at a given vehicle speed, while angle clamping determines what angle can be used at different speeds. The in-axis position ramping determines how fast the virtual axis can move at a given speed, while the angle ramping determines how fast the angle can change at a given speed. These ramps apply to the position and angle change by both the user input and the transition to the on-road state. The closed loop gain will determine the gain of the rear wheels at different speeds. The set point clamp parameters make it possible for a wider wheel angle at lower speeds while limiting the range at higher speeds. The maximum steer angle is used to set the maximum wheel angle of the slave axis. This is based on the geometry of the machine. The demanded wheel angle limit parameters set a max wheel angle for the slave axis when requested by the MMI. This is not used for the sharpest possible turning angle. For more information on multi-axis steering, please reference the multi-axis technical information as well as other multi-axis videos. That is all for this video. Thank you for watching.